Hello, this is Professor Lou from Carolina University, and this is our lecture about carbohydrates. Welcome. First, let's discuss simple sugars. Simple sugars include monosaccharides and disaccharides. Monosaccharides are glucose, fructose, and galactose. Disaccharides consist of two monosaccharides linked together. Examples are sucrose, lactose, and maltose. Here you can see the chemical structures of glucose, galactose, and fructose. Circles indicate the structural differences between the three. Let's take a closer look at glucose specifically. Glucose is the most abundant simple sugar in nature. It's also called dextrose. It gives food a mildly sweet flavor. It's usually joined to another sugar in foods, and it provides energy to the body cells. Note that the body very closely regulates blood glucose levels, blood sugar levels, and we'll discuss that in more detail as the lecture continues. Next, let's talk about fructose. Fructose is called the fruit sugar. It tastes the sweetest of all of the sugars. It occurs naturally in fruits and vegetables, and it's found in the various fruits, honey, and corn syrup. Next, let's talk about galactose. Galactose rarely occurs as a monosaccharide in food. It bonds to glucose to form lactose. Lactose is the milk and dairy product sugar. Now let's discuss disaccharides in more detail. Disaccharides, as we said, consist of two monosaccharides linked together and include sucrose, lactose, and maltose, as we just mentioned, lactose. So when we combine glucose and fructose, we get sucrose. That's called table sugar. It's the sugar that sits in the restaurant in the jar on the table. People put the sugar in their coffee. That's the sugar we're talking about. It's made of sugar cane and sugar beets. And it's listed as sugar on food labels. If we combine glucose and galactose, we get lactose. Lactose is the milk sugar. It's found in milk and milk products. As we mentioned before, some people do not have the enzyme necessary or do not have enough of the enzyme necessary to break it down. Those people are called lactose intolerant, and they have symptoms when they eat a lot of lactose. Here we can see the chemical structures of sucrose and lactose as examples of disaccharides. And as you can see, it's two monosaccharides linked together. Now, when we combine glucose and glucose, we get maltose. Maltose is the malt sugar. It seldom occurs naturally in foods. It's the product of starch breakdown and is found in germinating cereal grains. Now we're going to move on to the complex carbohydrates. And these are chains of more than two monosaccharides. We have the oligosaccharides, which are 3 to 10 sugar molecules. Examples of sources include dried beans, peas, and lentils. Then we have the polysaccharides. They are long chains of monosaccharides, and they have structural differences that affect how they behave in water and with heating. Some of them are digestible, and some of them are not digestible. So as we dig a little deeper about complex carbohydrates, we can learn about starches. Plants store energy as starch. It's found in grains, legumes, which are beans, and tubers, like potatoes and yams. These are long chains of glucose units, and there is something called a resistant starch, a starch that is not digested. Now let's discuss starch and glycogen. So plants have two main types of starch. They have amylose, which has long unbranched chains of glucose, and they have amylopectin, which has branched chains. Animals store glucose in highly branched chains called glycogen. So let's discuss glycogen a little bit more. Living animals store carbohydrate in the form of glycogen. This provides glucose when blood glucose levels get low. Highly branched chains of glucose units is what the glycogen is made of, and most of the glycogen is stored in our skeletal muscles or in our liver. Now let's discuss fiber. Fiber are non-digestible carbohydrates. Dietary fiber is found in plants, fruits, vegetables, legumes, and whole grains. Functional fiber is fiber isolated and added to foods. And then soluble fiber dissolves in water, while insoluble fiber does not dissolve in water. So what about the digestion and absorption of carbohydrates? Digestion breaks down carbohydrates into simple sugars. That process begins in the mouth when salivary amylase begins digestion of carbohydrates. But it's very important to note that in the stomach, the acidity of the stomach juices halt the action of salivary amylase and stops carbohydrate digestion. So remember that in the stomach, carbohydrate digestion halts. You may see that information later. Further on in the digestive process, we have the small intestine. Pancreatic amylase continues starch digestion there. We have brush border enzymes that digest disaccharides and other digestive enzymes that make an impact, such as maltase acting on maltose, sucrase acting on sucrose, and lactase acting on lactose. And what about absorption? The end product of carbohydrate digestion is glucose and galactose, which is broken down into glucose, and fructose, which is broken down into glucose as well. And then in the liver, our liver stores and releases glucose as needed to maintain our blood glucose levels, because as we said before, the body very tightly controls blood glucose. So carbohydrates of the body, they are very, very important. We have to have carbohydrates. We need all of the macronutrients, but carbohydrates have some very special roles, including our primary fuel source. Also, we use them for energy, quick energy to do what we need to do. All of our cells require energy to live and function, and this energy generally comes from carbohydrates. Carbohydrates also spare body protein. If the body does not have enough carbohydrates, it's going to break down things like our muscles, proteins, in order to get energy. We don't want that to happen. We don't want our muscles to be broken down to get energy. Our skeletal muscles, they're necessary to get things done, to walk, to do what we need to do every day. But what about our heart muscle? Our heart is a muscle, and it could be broken down for energy. So carbohydrates and a good source of carbohydrates in our diet make sure that our body doesn't need to break down our skeletal muscles or even our heart muscle to get energy. Also, carbohydrates prevent ketosis. So if our body doesn't have the carbohydrates it needs, it'll use a process called ketosis, which is a metabolic process where the body primarily uses fat for energy instead of carbohydrates. So this occurs when glucose, sugar, is limited, often due to low carbohydrate intake, fasting, or in certain medical conditions. During ketosis, the liver breaks down fat, producing ketone bodies, which then serve as an alternative fuel source for the body. But this is not a healthy process for us, and it's not something we would want the body doing very much. It's one of the many reasons carbohydrate intake is so important. So let's talk about blood glucose regulation. We have mentioned already that it's tightly controlled by the body. Why would we want it tightly controlled? If our blood sugar gets really, really low, we can't function, we can't think, and we could even die. If our blood sugar level becomes very high, also, we have major problems. We have major problems with our body systems, and we could eventually die from that high blood glucose level. We'll go into a coma and die. So the body very tightly controls our blood glucose level so that it stays within a narrow range. So what happens when we have an increased blood glucose level? Say we've just eaten a meal and blood glucose levels immediately increase, which is what they would do. Insulin is released from the pancreas, stimulating the uptake and storage of glucose. So there you see the pancreas releasing insulin, and what happens after the insulin is released is our body can now use this glucose. It puts the glucose in the form of glycogen in our muscles. It puts the glucose, turns it into glycogen, and stores that in our liver. It takes the glucose and stores it in our fat-storing cells. This all lowers glucose levels. The glucose is being used, and it's removed from the blood. Then our blood sugar returns to a normal level. Now, what if our blood sugar, instead of needing to go down, needs to go up? Well, let's look at the bottom of this illustration. You can see that there's a decreased blood sugar level. Several hours after a meal, blood glucose levels drop. Glucagon is released from the pancreas, and that stimulates the breakdown of glycogen into glucose and the synthesis of new glucose. So you can see here the pancreas is very, very important here as well, releasing glucagon, and then our body is going to make glucose and then also release glycogen so that it can be used forming glucose, and then that glucose is released into the bloodstream and our blood sugar levels return to normal so that we can think and function and move and live. So this is an important process. Things can go awry when there is an interruption. One of the most famous ones is when we cannot make insulin. When that happens, there's something called type 1 diabetes that would be the diagnosis. When someone can't make insulin, then they need that insulin replaced in modern medicine, and they can live a normal lifespan. But if that wasn't possible, like before we realized we could give people insulin, this process goes completely awry. They cannot process the sugar, they cannot use it, and they go into a ketotic state, and eventually the person would die. So this is a hugely important process. Our body has to have glucose. It has to have this for energy, for us to live and do well for very long. And so the body tightly controls our blood glucose level to make sure that we can function as humans and our cells have what they need. So what is some guidance about carbohydrates? First of all, let's discuss the recommended intake of carbohydrate. The RDA is 130 grams per day. The dietary guidelines are reduce the intake of added sugars, AMDR for added sugar equal or less than 25% of daily energy intake. Choose whole grains, vegetables, fruits, and cooked dried beans and peas, and consume more than half of all grains as whole grains. Well, unfortunately, we're not doing too well at meeting these recommendations and guidelines in the United States. So what are we actually eating? AMDR equal to 45 to 65% of kcals. The average American adult, 49 to 50% of kcals are carbohydrates. 13% of adults' total caloric intake comes from added sugars. That's a lot. And that is mostly from high soft drink consumption, milk consumption, and vitamin and mineral quality of the diet is going down in part because of this high soft drink consumption. So this is a big problem. We're trying to educate people in the United States to change this so they can have a healthier diet and be healthier overall. So what can be done to improve this? And what is the role of public health? Well, we need to continue to try to help people understand what the appropriate amount of carbohydrates is in a diet, in a healthy diet, and then also where to get those carbohydrates, that they're not all the same, and that the complex carbohydrates are much healthier, and the simple carbohydrates like are coming from high fructose corn syrup and other sugars in soda and in some of the other foods we're eating is really very detrimental to our health, and we should switch over to the healthier carbohydrates. These are very important messages to get out to the public. We can also have policy changes. Now, that is very hard to do because the public tends to resist policy changes. An example is, at one time, New York City wanted to restrict the size of soft drink cups and cans to make them smaller for portion control and try to help people consume less sugar. This did not go over very well. The public was very, very resistant, and it created a lot of problems about personal rights and freedom. And it was really just intended to try to help people consume less sugar and be healthier, but that is not how the public took it at all. And so we have times that we try to make improvements, and we end up creating a lot of turmoil, and it's not very successful. So at this point, we're trying to educate the public on what they can eat and drink in terms of carbohydrates to help them be healthy and to help them reduce their risk of health problems, because we know that, for example, eating a lot of simple sugars, eating a lot of high fructose corn syrup, a lot of sucrose, this is going to put them at risk for certain diseases, including and probably most importantly, heart disease, which is the #1 killer. So also puts them at higher risk for cancer, which is another huge killer of Americans. So we want to try to educate them, but we want to do so in a way that empowers them to make good choices. Also, in our personal lives, we can follow the guidelines and follow the recommendations as much as possible. A lot of people are not even looking at how they meet the guidelines or if they meet the guidelines. They don't even know the guidelines exist sometimes. And so we can do that in our personal lives. We can educate those we know. If we have a professional role, like maybe we're a teacher or maybe we're a coach, maybe we're somebody that has the opportunity to teach members of the public about what we know about nutrition or to direct them to good, positive sources of information that is reliable and scientifically based, so evidence-based information, then these are things that we can do. And if we are actually public health workers, then we can definitely look at the literature, look at the evidence, and try to provide the best information we can to the populations we're working with. Thank you very much. I hope you've learned information that's useful to you in this lecture about carbohydrates, and we'll go on to lipids next time.